Hello. So 4, 6. Which one?
Number 430.
430. Oh, okay. I like it. You're working. 430 says, find the equation on the line that goes through those 2 points.
What is it, 8-1?
So it is. Yeah. So we did a problem like this yesterday. What are the 2 things you need anytime you get a problem that says find the equation of the line that? What 2 things do you need for the equation of a line? And what do you do if you don't have the y-intercept? No. So what you really need is a point and the slope. If the point happens to be the y-intercept, kick ass. So if I had a point, if I had the y-intercept and the slope, I could use this equation. Come on, one of these markers is going to work. Green? Right? If I had the y-intercept and the slope, I could use this equation. But if I have any slope, if I have the slope in any point, I can use that. So this always works. This only works if I know the y-intercept. So in this problem, do I have the y-intercept?
Yes.
How do I know that I don't have the y-intercept? Because neither point has x equal to 0. Because how do you find the y-intercept? You make x 0. So for a point to be the y-intercept, it has to be 0, comma something. And I don't have that. Damn! So I can't use this. I don't know what b is. Do I have a point? Yeah, I got 2. You guys stay with me. So I have a point. So I can use either one I want to. What am I still missing, though? The slope. So how in the world am I going to find the slope for this? Yeah, y2 minus y1. I like it. You guys with me a little tiny bit? Or a lot? One of those 2 things. So you would do y2 minus y1 over x2 minus x1. That's the slope. And then you can pick either point you want to and put the x piece there and the y piece there. Yes, no, maybe so?
Yeah.
So this is exactly like one of those problems we did yesterday. I like it. Is that right? Any other question from homework stuff? Let's see. All right, here goes a really freaky ass question. Let's do this one. This will be exciting. I'm excited. You should probably be scared. I don't know. What have I said? Find the equation of the line with the same x-intercept as 5x minus 2y equals negative 15. And perpendicular to 3y minus 2x equals 11. Oh man! The shit, Jeff. Sorry. It's like a Schmeagol and Gollum. Be nice to them. No, don't be nice to them. So, does everybody get the idea what's going on here? Even if you're not sure what the hell to do with this, you want a line that has the same x-intercept as this line's x-intercept. And our line has to be perpendicular to this one. So what you do for yourself, see how it says find the equation of the line. All right, screw the rest of it for a second. What two things do you need? Oh, dude. All right. You're my new favorite. Damn, can't quite get high. What two things do I need always to get the equation of the line? I need the, you can do it. All right, stay with me. Come on. What two things do I need for the equation of a line? Slope for damn sure, right? And then more generally, a point. I like it. So I need the slope and I need a point. Which piece of information relates to my slope?
That it's parallel,
5x.
perpendicular to.
So this piece will help me with my slope. So if I know my line is perpendicular to that one, if I knew this guy's slope, my slope would be
The opposite.
the negative reciprocal. I love it. How do I figure out this guy's slope? How do I figure out any line's slope? Solve for y. You gotta put all this together. The quickest way to know the slope of a line that's given to me in equation form is to solve for y. Why? Because then it's y equals mx plus b, right? You guys with me? So anytime, any reason you need the slope of a line and you have its equation, solve for y, because whatever's in front of the x is the slope. That's the power of mx plus b. Do I have a reason to know some slope? Yes, I do. What's this guy's slope? And then I can figure out my damn slope. So let me solve this dude for y. So let me add 2x. And then, is that cool? Add 2x. Trying to solve for y, and then divide by 3. Look at that, that's gross. Who gives a shit? What's this guy's slope? 2 over 3. So what's my slope?
Negative 3 over 2.
Negative 3 over 2. Check, I know the slope. Now I move on to this. Do I care about that line anymore? No. All I had to do with was my slope. I'm done with him. Throw him away. Get out of here. So how do I figure out a point that my line goes through?
You solve the other equation where y is 0.
Yes. If I knew this guy's x-intercept, I would know my line's x-intercept. That would be a point. So how do I, like you said, how do I figure out this guy's x-intercept? I make y 0, right? All right, let me stop for a second. This problem, you see why I love this problem, because it has basically everything we've talked about so far in it. And you're like, no, Jeff, God damn it. I don't want math stew. I want math one bit at a time. I give you math stew sometimes. This is the whole thing about math. If you write these for yourself, you can then focus on each one individually. What has to do with my slope? Perpendicular. Okay, let me focus on that. Done with it. What has to do with my point? This guy. If I knew his x-intercept, I know a point that my line goes through. Then you think, how do I find this guy's x-intercept? I make y 0, right? So then if I make y 0 in here, I get x equal to negative 3. So what's that point? Careful.
3, 0.
X is negative 3 when y is 0. All right, so now I know the slope, I know m, and I know x1, y1. So then I can throw all that together. Let's see. Yeah, you're just not going to work, are you? No. Which one am I good? Read my good one. Y minus the y piece of my point is what?
0.
0. M
Minus 3.
x minus the x piece.
Negative 3.
Yeah, so let me just go ahead, is that cool if I just make that plus 3, all right? Minus and negative. And what's really kick-ass about this is y minus 0 is y, and so when I distribute, I'm done.
Yay!
You forgot? Yeah, you got it, John. Good job. All right, I'm gonna stop. That was definitely the hardest example of that kind of problem. But if you break it down, it's hard because there's a lot of steps to it. But if you break it down this way and you focus on one thing at a time, I gotta figure out the slope. What has to do with the slope? This does. Okay, I got the slope. Point, I gotta get a point. This tells me a point. Okay, let me figure that out. And then I can, it doesn't, and then here's the cool thing. No matter where these two came from, no matter how I figured these out, that'll be M, this will be X1, Y1. No matter where the shit they came from, the minute I get them, I can throw them in. So then I kind of forget all this shit, and I just focus on what I know and put it in. It's what I used to call the SDT. No matter where this came from, you do the same damn thing. You throw them in, and you solve for Y. Oh, you guys love that, I can tell. All right. And again, that was an example of the hardest kind of problem I would give you. And I really hope you guys notice how it's still, you need the slope. What did they tell me that would get me my slope? You need a point. What did they tell me that will give me a point? So that's how you focus your attention.
Be right back.
Sure. Okay. Any other thing from homework before I? All right, so we've got, so we got this here? We know this form of a line, and we know, here's my bad one, this, hello, here we go. All right. You can have that, Phil. It doesn't work too well, so no, you don't want it. All right, those are my two equations for a line. Kick-ass, right? So if I gave you this equation right here, let me see if you guys can do this. Can somebody tell me what the slope is? Let's start with something easy.
3/1.
Yeah, you guys see that? The slope will have to be the number that's right there, in front of the x, like always. So the slope is 3, and you said 3/1. That's even better. I love it. Can somebody tell me a point that this line goes through? This is going to be the hard part. See how there's a plus right there?
Yeah.
So what must the x piece actually be?
1.
Not 1.
Negative.
-1. If x was 1, shouldn't this be x minus 1? Right? If x1 was 1, it would be x minus 1. It doesn't say x minus, it says x plus 1, so it should be x minus -1. So if there's a plus sign, we know that actually means it was a negative piece. That's why the negative became a plus. Comma what? 7. See, that's minus, so that's definitely going to be the thing. All right. So we've done problems where we created that equation, but what if they gave you this equation? Can you pick out the pieces? That's being able to do it both ways. Is everybody semi with me? That's all it is identifying what's in which place, and so you know what's what. You have to be able to do that this way, just not as fine-tuned, really. Okay. And then what if I gave you, there's one example. What if I gave you, here's something even easier, hopefully. Right, what's the slope here?
-3/4.
Yeah, -3/4. What's the y-intercept?
0, 11.
0, comma, -11. 11. Okay. All right, I'm not getting enough feedback from you guys, so I'm going to make you do a problem. See, maybe this will teach you say something. You guys graph this line. Without doing anything to the equation, I want you to graph the line. You can figure out what you need from the equation, just don't change the equation. Before you get too far, what's the slope? Let's start there. Negative 1 over 2. I like it. And what point does this line go through? Careful. What point does it go through? The point 2,
4.
negative 4. Did you get those? They said not to do that. Because they didn't want you to. See, negative times negative is positive. Yeah, there you go. But, yeah, that doesn't help you. So, yeah, So I didn't want you to solve this. I didn't. I want you to be able to use it as it is. To tell me these. Is everybody cool with this? You guys see that? That's a plus 4. The equation has a minus there, so that y piece has to be negative 4 minus a negative is positive. The x piece is 2, because it's x minus the x piece, and that's 2.
Yay.
Maybe. And now you just have to graph this. We've done that a lot. You plot 2, negative 4. So 2, negative 4, and then where am I going to go from there? I'll tell you where you can go, Jeff. I'm always curious if anybody's thinking that. I'll tell you where you can go, Jeff. Huh? I have to go where?
Down one.
What's that mean? Yeah,
Point.
down 1
Oh, I'm sorry, down 1 over half.
over 2. Down 1 over 2.
Oh.
Down 1 over 2. I could also go up 1, back 2, and I'm still on the same line. We are. Yeah, I like it. So no matter where I get the point and the slope from, you're able to graph it. No problem. Okay, moving on. So now let's see what we can do with all this knowledge about lines. And weirdly enough, I'm going to take a step back and remind you about something. So what we're about to explore is related to inequalities. So if I said graph this inequality, we've done this already. Can you just do it? Go ahead. Do it. Do it. You can. Oh man, I need some kind of medication. All right. Maybe some water will help me out. Going a little loopy right in front of your eyes. That's not water. What is that? Whew. All right. So to plot x greater than or equal to 3, we've, to be really honest, I don't care if you use circles or not, but we should be better than that. What symbol would I put on the 3? Well, let's start there. Which way am I going to shape? Yeah, that way. The way that it's pointing, right? Greater than 3. And why do I shade that way? Because is 4 work? Is 4 bigger than or equal to 3? Yeah. Does 2 work? No, I didn't even have to try to because I know one side of 3 is all answers and the other side is no answers. So I know I'm going to shade this way because that way worked. And then the symbol I'm going to use is that one. I don't know if you guys remember. You got the Kamehameha. Wow, there's that one. Okay. I like it. So what the hell has this got to do with lines? Okay. So what if I had this instead? X plus y is bigger than or equal to 3. So what I want you to realize, the actual idea doesn't change at all. It's just up here when I have a single variable, I'm talking about one number line, right? How do I cut a number line in half? At a point. Chip, right? And then it's cut in half. Are you with me? Yes? So a single variable, unless otherwise stated, would be just one number line. And to cut it in half, I would just put it at I just have to put, pop, I just have to put a dot there, and it's cut in half. If I have a rectangular coordinate system, oh shit, a plane, like this piece of paper, how do I cut it in half? Or in parts, and then it have to be perfectly in half, but just, yeah, I like what you just did. Do it again. Yeah, he's just chop it. Yeah, chop it. Right? Chop it, and what does it create? Is everybody cool with that? If I cut this in half, wouldn't it be like chop? Or I could even chop it this way, chop. What shape have I made along the plane? If I cut it in half, what shape have I made? Chop. A line. Okay. So to cut a number line in half, I need a point. To cut a plane in half, I need a line. So what's going on here is, on this number line, where are the x's bigger than 3? Over here, right? That's the basic idea there. Here it's going to be, what area has it so that all the points add up to be at least 3? So the easiest way to look at this is to kind of make it related to this. If I solve this for y, I get this. If that was an equals, that would just be a line, right? Sort of like if that was x equals 3, wouldn't that just be a point? Bump, I'm done. Correct? And then when I put the inequality, I'm going to shade one way or the other. Let me say this again. If that was x equals 3, it's just a point. If I put an inequality in there, then I'm going to shade one side or the other of 3. If that was an equal sign, it would be a line. With an inequality, I'm going to shade one side of the line or the other one. The idea doesn't change. I just change how many dimensions I'm working in. Ooh, shit. So can I graph this line? What do I know about that line? So the first step is to kind of ignore the inequality for a second. Just look at the line. What do you know about this line? Tell me something. What about -1? That's the slope, right? -1 over 1, right? Where do I start though? What's the other thing that I can get? The slope and the y-intercept. What's the y-intercept? You give me better. There it is. I like it. So I start at 0, 3, and then I go down 1, over 1, down 1, over 1, down 1, over 1. Man, my scale is sucky. These things happen. All right, here's my line, right? But I'm not complete yet. That's if it was an equal sign. Sort of like if I would have put that, but the question was this. I still have to shade. So one way to do this, it's sort of like I said earlier, why did we shade that way? Because 4 worked. So now watch this. This line is a dividing line between good and evil. No. Between answers and not answers. If I pick a point and it works in this inequality, then I'm going to shade that way. Let me say this again. An entire side works and the entire other side doesn't work. So once I get one point that works, I know that side is the side that works. I'm going to shade all that shit. The best point to check is 0, 0. That's the easiest thing to put in here. So if I put 0, 0 into this inequality and it works, I should shade that way. If it doesn't work, I should shade that way.
And it will always be 0, 0.
If your line goes through 0, 0, then you have to pick something else, and then I would pick like 1, 0 or 0, 1. I like zeros because that kills whatever that variable is, makes it easy. So when you put 0, 0 into this inequality, does it work? Is 0 plus 0 bigger than or equal to 3? No, it didn't work. Right? Since one side is all answers and the other side is all not answers, where should the answers be then? That guy didn't work. Where are the answers? Over here. Every point over here works in this equation. Give me a point that works. What plus what is bigger than or equal to 3? 3 plus 2, let's say. Is the point 3, 2 in here? Yes. Do you see what I'm saying? For them to add up to be bigger than 3, that means that neither one can be too small, too big negative. That's why it eliminates all this. This is what works because then the sum is bigger than 3. That point sure works because that's a big ass x and a big ass y is going to be way bigger than 3. Yes?
What if the y is negative? Like x negative y?
Oh, well, sure. If y was -1 and x was 6,
No, like just in general, like you're just doing the equation x plus negative y.
oh, you would still solve for y.
And then you divide it by y. Negative
By
y.
negative, yeah, and then you flip the sign, exactly. So everything that works with inequalities, you have to be careful about here because they are inequalities. So we'll do one like that next. I see what you mean. So, believe it or not, right now I get the feeling that more of you don't believe me than do. These are the same problem. We figured out where the dividing point, in this case line, is. Right? Y equals this is the dividing line. But since it's greater than, it's got to be one side or the other that I shade, the same way that the difference between these two things. Really want you guys to see this. So instead of a point with a line, I have a line with a plane that chops it. Let's try another. Yeah, let's do one like you said here. Let's see. What you got, Jeff? It doesn't matter. That's a good point. Sure. So how do I solve for y? What do I do? Yeah. So what I'm trying to do now is to get the line figured out so I know what to graph. Is that solved for y yet? No. So here's Stuart's point. I have to do what to solve for y? Divide by -1. So y, and that's 2, and that's -4, right? What happens here? Sign has to flip. Remember that? It doesn't suddenly not do it just because we're in a different section. I mean, that's just a rule. Is this an inequality? Yes. Did I divide or multiply by negative? Yes. Sign's got to flip. That is a rule. We talk about why that makes sense. We know why it makes sense. Maybe. And so you guys do this one. Graph the line, and then figure out which side to shade. And then I'll show you the shortcut that I use. After you got to do the work? Yes, after you got to do the work. Ha, ha, ha. You would be better over there. Let's see. Well, you'll see. Phew, okay. All right, so to graph this sucker, what's my y-intercept?
0 minus 4.
Yeah, 0, -4. And then I go up 2, over 1. Up 2, over 1. All right. I put my line. Holy crap, Joe. Just let it go, dude.
Can you see?
What's
one
up? Sorry.
number-
Sorry?
When you see the slope, one number is gonna be over 1, like just number 1. is
Not an
going-
assumption, it's just true. Right, what we do is, what is 2 divided by 1? 2. So anytime I see a 2, I actually know there is a 1 underneath that we have all decided we're not gonna write.
Yeah, like
Yeah.
if you see 6, 7.
It'll be
7,
over 1. Which is good, because slope is rise over run. So the people that forget to do that, they might not run it all, and then the line is like this, and it gets all freaky. Now I gotta figure out, so if this was equals, I'd be done. It ain't equal, damn. So, is 0, 0 an option for me to use? Yes, because it's not on the line. You guys see that? If the line went through 0, 0, I have to use something else. So I can use 0, 0. Go back to the original, just in case I made a mistake here. Is 0 minus 0 greater than or equal to 4? Is that true?
No.
No. I really want you guys to get this. That point did not work, therefore this side must be all the not answers. The other side must be all the answers. And just to check, what point is this? That is 3, -2. So let's see, if I put a 3 and a -2 in, 6 plus 2 is 8. Is that bigger than or equal to 4? Check. So that's another way you can check is once you shade, pick a point over there and see if it actually does work. The shading should be all the points that actually work in here. And the not shading is all the points that don't work in there. All right. Stay with me. Yes?
I'm sorry, Clarence, can you repeat again where it says y is not equal or not greater than 2 over 1 x -4?
I'm sorry.
And how did you graph that?
So what I'm doing is I'm ignoring the inequality at first.
Okay,
Because when I go to graph x greater than or equal to 3, the first thing I do is figure out what number to put here.
great.
Did that care about which way that was facing? Did the 3 care that which way this was facing? No. So I put the dividing point first, and then I figure out which way to shade. So I just forget that's an inequality, and I graph that line, slope, y-intercept, right?
So you went 2 over and down
No,
4?
well, 0, -4. Rise over run, rows 2, ran 1. Rows 2, ran 1. Just like we were doing before. Nothing's changed about that. It can't change. The only extra thing is, oh shit, that's an inequality. I've got to shade one side or the other. When it's a single variable, it's a single line, only shade on a line. Here, it's two variables. I've got to shade one side or the other of that line that I made.
So my y-intercept on the graph.
It's still 0, -4 like it should be. mx plus b, right? Still. Yeah, that can't change. We're just gonna do more stuff with it. Yeah, I like it. Yes.
So the not shaded is all the things that work,
No.
that don't work?
No, come on. Where do you
No.
shade? Don't you
No, I
shade?
think that I'm talking about, you said it before.
I know. But what does shading mean? What does shading always means? That's where the
All the numbers that work.
work. That's all the numbers that work. That's what the shading means. Those are the numbers that work. So where I shade are all the points that work. That's why if I test a point and it works, I shade that way. If it doesn't work, I shade the other way. Okay, so let me give you this. Oh yeah. Okay, so let's see. Do I want to? Sure. Let's do this. No. All right, let's see. Today's lecture brought to you by Panasonic. Panasonic. It's an option. Okay. All right, good. All right, so let's kind of take a step back a bit. Let's kind of build this up a slightly different way. X plus y less than or equal to 2 is a linear inequality, right? All the points that make x plus y equal to would be an answer to this. Do you guys see that? If x plus y has to be less than or equal to 2, then obviously all the points that make it equal to work. So can somebody give me some points that work? Say again? 0 and 1. Does that work? What's 0 plus 1? 1. Is that less than or equal to 2? Yes, beautiful. Give me another one. Yeah, 1, 1 works because 1 plus 1 is 2, which is less than or equal to 2. What about -1, -1?
Yes.
What's -1 plus -1? -2. Is that less than or equal to 2? Hell yeah. Right? Aren't negatives less than positives? Yes, I like it. Kick ass. So take a minute and graph this line. You can solve for y, get your intercept, or you can actually just get the x and y intercept. Doesn't matter. Just plot that line. However you want to. You can solve for y, get the slope and the y-intercept. Get the x and the y-intercept. It's like moonshine. Keep me going. So if I do solve for y, what's the y-intercept? 0, 2. And then from there I'm going to go
Down 1 over.
down 1, over 1, down 1, over 1. All right, so there's the line. Oh, crap. Make that big. There we go, Jeff. Now, if you just plot some of these points that we said work, 0, 1 is right there. -1, -1,